So we're going to be looking at slopes and equations of lines. First of all, we got to talk about what increments are. So that's basically going from one point to another point. So when a particle in the plane moves from one point to another, the net change, which is the increments in its coordinates, are found by subtracting the coordinates. So that's the change in x and the change in y. So if we look here, that's what we're talking about here. The change in x is found by subtracting your two x values, and the change in y is found by the same method. So if we look here, find the increments, and so we're looking for the change in your x value. So let's say that this is coordinate 1 and this is coordinate 2, and that's very important. You got to stay consistent. So you would have the change in x. So you would go from coordinate 1 to coordinate 2, so then that would be 0 minus 0, and so then the change in x would be 0. Then you would have the change in y from coordinate 1 to coordinate 2, be consistent. That would be from 4 to negative 2, so 4 minus negative 2. That would be 4 plus a positive 2 minus a negative. And then that will give you 6, and 6 is that change in y. So then those are, by definition, what we consider the increments. Now taking a look at the slope, because the main focus on this video is slopes and equations of lines. So first of all, let's get the definition of slope. You did this in Algebra 1 even before that, so I'm not going to spend much time on this at all, but slope is basically it's the rise over the run. If you're looking at a line, how far does it go up versus how far does it go down? And that up change, or the rise, is designated as the increment change in your y, and your run is the increment change in your x. Parallel and perpendicular lines. Parallel is, remember, if they have the same slope. So if they have the same slope, they're parallel. Perpendicular are opposite reciprocals. So you reciprocate the slope and then you take the negative of it. Okay, so if it was positive, it becomes negative. If it's negative, it becomes positive. So perpendicular, opposite, reciprocal. So the first equation that we're going to look at here is the point slope equation. And the point slope equation is y is equal to the slope, remember, which is m. So let me just jot that down for you. M is the slope. And x1 and y1, these two coordinates are the point that you're going to use. Okay, the actual values. So you're given a point in this problem and then also the slope, hence the point slope. Another form of an equation is the slope-intercept form here. So you have the slope-intercept form, and that's y is equal to mx plus b, where m is your slope again, and remember b this time is where the line crosses your y-axis, and so that's what we call the y-intercept. Alright, so if you're given the slope and y-intercept, use this form. And then the general, or the standard form, as it's sometimes called, of a line is ax plus by is equal to c. And also the thing that you have to remember about that is that a, b, and c, if it's in standard or general form, a, b, and c are integers. And remember, the definition of integers are positive and negative whole numbers. Okay, let's go ahead and do an example here. So first of all, you want the equation, and they even specifically tell you point slope. But if I didn't tell you this, okay, if I didn't tell you what form I wanted, and look at this. Look, I give you a point, I give you a slope. So what are we going to use? We're going to use the point slope form. So first of all, figure out what information am I given, and then figure out what equation am I going to use. So point slope form is usually the most popular, so it's going to be y minus 1. So y minus y is equal to your slope times the quantity of x plus 1. So x minus x, so that ends up being x minus a negative 1. Okay, and then you can stop there because that's point slope form. Or you can put it in your y equals by taking this -1 and distributing it in, and then bringing this -1 over and adding it. And when we do that, you would have y is equal to -x minus 1 plus 1. So you'd have y is equal to x. Okay, so either answer, I believe, would be correct, but since it technically said point slope up here, this is the point slope form. Okay, just be familiar with putting it in any form that I want. On this one, go ahead and try this. Pause the video, try it on your own, see how you do. It's not going to hurt, and then come back and check your answers, see how you did. But this time, I want it in slope-intercept form. So we're going to use the slope-intercept form of an equation, which is y equals mx plus b. So y is equal to m, which is the slope, x plus b, so that'd be plus and -1. And then that's it. That's the equation of the line. And then the general linear equation, this is a little, requires a little more work. So when you're given 2 points, you can go ahead and put it in the 2-point equation, which isn't given here. But usually the first thing what I try to do is find the slope. Alright, so the slope, remember, is the change in y over the change in x. Okay, so you do 1 minus -2 over -2 minus 2. And then when we simplify that, you end up with -3/4, and that's your slope. Now once you find the slope, choose a point. Doesn't matter, -2, 1, 2, -1, doesn't matter. So I'm going to choose -2, 1. Then you're going to go ahead and put it in standard form. So now that we have a point slope, let's put it in point slope form. So it's going to be y minus 1 is equal to your slope, which is -3/4, times x minus x, which is minus -2, so that's plus 2. And when you simplify this, you'd have -3/4 x minus 3/2, bringing that 1 over, so that'd be plus 1. And let's go up here. And then putting those together, you'd have -3/4 x minus 1/2. Now, what you need to do is go ahead and get rid of the fractions, because remember, in standard form, you can't have any fractions. So we're going to go ahead and multiply everything by the greatest denominator, which is 4. So when we multiply through everything by 4, you have 4y is equal to 4 times -3/4 x minus 4 times 1/2, and then simplifying there, you'd have 4y is equal to -3x minus 2, and then bring this -3x over, you'd have 3x plus 4y is equal to 2. And here you have standard form or general form, whatever you want to call it. Okay, so now you're an expert with putting things, not only finding the slope of a line, parallel, perpendicular, but also putting it in equation of a line, whether it's standard, whether it's point slope, whether it's slope intercept. Now let's go ahead and try an application. All right, so on this one, so sometimes let's go ahead and just review what a scatter plot is, regression analysis, the regression curve. You use your regression analysis in your calculator to find what's called a line of best fit, depending on who you had for your algebra classes. It's also called a line of best fit. And then the regression curve, okay, is the actual graph itself. Alright, so our goal is to take data like this, like what we see here, and this represents age and weights of 9 girls. So you're looking at the age, which is in months, so from 19 months to 43 months, and then the weights from 22 pounds to 39 pounds. And so just to give you an idea, my 16-month-old is about 25 pounds. So she's in the upper range of what she should be. I think she's in about the 70 to 90 percentile. She's a little chunk. Anywho's, what you want to go ahead and do is you're going to use your calculator and you're going to go into stat, and you're going to go ahead and edit your table. And this, since these are your independent variables, time, which is months, doesn't affect anything. However, the weight is affected by time, and so then this is your y variable. And so, this would be your L1 and L2, or however, you can be L3 and L4, it doesn't matter, okay? Just when you go through and run this thing. More commonly, it's going to be L1 and L2. So let's just go ahead and do that. You're going to put this data in L1, this data in L2, and then once you have that, go ahead and come back here to this video. So pause it and put that data in there. Now once that data is in there, what you're going to do is you're going to look for linear regression. So it's going to be under the Stat menu. Then you're going to go to Calc. And under there, you should see an option, something like linreg. Depending on if you're using a TI, it should be linreg. Depending on what calculator, what version that you're using, could be called different things. Okay, but linear regression equation is what you're looking for. So go ahead and do that, and then come back to the video, see what you get. And in fact, try to answer all these questions on your own, then come back to the video and see how you did. But the equation here that you should get is y is equal to 0.680 x plus 9.013. Okay, that's our linear regression equation. So now it says find the slope, and our slope here is the 0.680. Then interpret it. When we interpret, what does it mean? Well, in this case, it's the average of the change in weight per 1 month. WIGHT, there we go, per month. Okay, because remember, it's change in y over the change in x, which is the slope, and it's the y variable was the weight, so it's the change in the weight over the change in the month. All right. So now what you're supposed to do here is superimpose the graph. What you want to do is you would have the scatter plot up at the same time, and then go ahead and in your Y1 menu and your graphing function, graph it. And just see how closely it actually matches your data points. So, if these are your data points, something like this, then your graph should somewhat closely, it's going to be linear, it's going to be a straight line, closely match those data points. Just double check to make sure. If not, then you did something wrong. Just make sure you ask me in class if you didn't get something that matched, because it's important that you are. Last question, use a regression equation to predict the approximate weight of a 30-month-old girl. Now, the time, the months, that is, remember, your x variable. So in our equation, we're solving for y. So it's going to be y is equal to 0.680 times 30 plus 9.013. And we're going to go, when you simplify that, plug in your calculator, you get something about 29 pounds. All right, so according to the statistical data, a 30-month-old girl should be 29 pounds, and that's what they'll tell you. Anyway, just to sum up, the idea of this video was to be able to graph equations given 2 points, given a point and slope, whatever, be able to graph an equation of a line, find the slope, and then also apply that by use of a regression analysis, regression curve, and stuff like that. Okay, so again, make sure you have these done in class, and we'll see you.